Good morning, good afternoon, and good evening. Thank you for joining today's webinar, Quickly Solve IoT Data Processing and Management Challenges, brought to you by NXP, PHYTEC, and Idia. All attendees are muted. If you have questions during the presentation, please enter them in the question box in your GoToWebinar user interface. We will have a period of Q&A with our presenters at the end of the presentation. You will find a copy of the slides for this presentation available in the handout section of the GoToWebinar user interface. Without further ado, I will hand the presentation over to PHYTEC.
Hello, everyone. Thank you for joining our webinar. The topic for today is going to be how to quickly solve IoT database and factory automation challenges. This is a collaborative effort between PHYTEC, NXP, and Idia. Now, from my side, my name is Fernando Benitez. I'm the Technical Sales Manager at PHYTEC. Joining me as speakers, I have Susan Montessori, who's the President of Idia. From the Idia side, I have also Ryan Phillips, who's the Product Architect. And then from NXP side, I have Justin Mortimer, who is the Director of Mass Market for Industrial Edge Processing. We're very excited to be doing this webinar also in Mandarin, thanks to our teams in China. In this webinar, first we're going to kick it off with a factory automation demo. Then we're going to take that demo and break it down and show you what steps and solutions we took to achieve this demo. After that, we're going to give you some next steps and action items that you can take from this webinar. We're going to end it all off with a live Q&A session. Please feel free to post your questions in the chat. We're going to gather all those questions and we're going to answer them at the end in that live Q&A session. Now I'm going to pass it on to Ryan, who's going to kick us off with that demonstration.
A significant problem that device manufacturers face when designing software for their devices is how to process the time series data produced by various sensors in real time. There is a high volume of data being produced by those sensors, so they need to be processed with high throughput, and those sensor readings represent real-time events, so software needs to react with very low latency. And there are many different decisions that need to be made based on that data at the same time, so that the data can be either presented to end users in the form of alarms or captured to the local flash media on those devices. In addition, the data needs to be able to communicate to other devices on the network. And since the devices are holding all of this valuable information, it's important to secure that data from cyber attack with intelligent agents and other tools on the devices themselves. So today I'm going to highlight these issues by looking at a specific application. Let's say you are developing software for an industrial drilling machine. It is going to be collecting information from temperature sensors for the temperature of the drill bit and pressure sensors measuring the cooling liquid that is applied to keep the temperature in check. So that information is going to be available for not just one drill, but possibly many drills on a factory floor. But we want to be able to use that information both for the operation of the drill and also for long-term maintenance queries. So in order to do that, we have a edge-based embedded board that is installed at the machines themselves. And we're going to deploy i2DB onto one of those embedded boards so that the sensors can provide their data to i2DB and the various applications can query that data in order to make the decisions they need. So Today, I'm going to be showing how to simulate those sensors and applications in order to prototype this application, but I'm going to be deploying ETDB SQL to an actual ARM target device, a PHYTEC i.MX 8M mini, and I have already loaded ETDB SQL onto this device, but haven't set up anything else. So we're going to start by running the ETDB console command, which starts at the Idia database engine with an embedded web server so that I can connect from my desktop system and access the data that is being processed on the device. So to get started with this problem, I'll need to inform ETDB about the type of sensors that we want to collect data for. So anyone who has worked with a database before knows how to create a table to capture data with any schema that they want. But I'm going to be creating an IoT stream so that we can capture that data as it is produced in real time. And to do that, I'm going to use this browser window on the left to represent the IoT sensors. And by going to the Content tab here, I can dynamically generate sample data for a random selection of sensor values for 10 different drilling devices. So I'll just start generating some data. And what this is doing is passing that data to the embedded board and then just showing what the embedded board is receiving from the simulated sensors. So the most recent reading is appearing here, and you can see it cycling through the different sensor IDs so that we will be able to simulate these 10 different sensors. Now to actually use that information, I am going to run a continuous query. And what this does is allows me to monitor the most recent temperature reading across all of the different sensors that are producing data. So this table is dynamically created and updated in real time as new data arrives from the various sensors. But this is just showing the current value for all the sensors. I can increase the data generation rate if we want to test out how quickly the device itself can handle the data coming through. But for today, I'll keep it going slow and steady so that it's easier to follow along with the queries. Now, most applications are actually going to be interested in looking for very specific events in the data. Let's say we have a query that's only looking for high temperature events where the drill bit has overheated and is above a temperature of 70 degrees. With this query running on the device, this client application is just receiving notification of when there is a change to the results of the query. So whenever a device reaches a higher temperature, it gets added to this table. And when its temperature falls back into acceptable levels, it gets removed. And so from a developer's perspective, this is very convenient because you just specify what information you want to see, and you will only receive notification when that data changes. Another important consideration, though, is we may have a number of different queries to run on this data at once. And so I can just open up another connection by opening another browser tab. And so, for example, if we want to calculate the volume from the temperature and pressure, we can enter a simple formula for that. And by running this continuous query, we get constant updates of the current volume. That information can be used for filtering, grouping, aggregating the data, but I'm just showing this simple query to get started. So with these two queries running side by side, we're now capturing a lot of information and we're able to display that, but we'd like to also collect and store some of this data on the flash media on this embedded board. So to do that, I'll just go to the persistent database that was created as a file on the flash media and create a table there to capture those high temperature events more permanently. So with that table created, I can now go back and use a continuous query to insert anytime that a high temperature event occurs. This information will be saved into the high temperature events table. So with that running, I can look at the table, look at its contents, and you can see it started to capture some of that information from the results of that continuous query. So that's allows us to save the information as long as we need and use that for more long-term decision making. However, it may not be enough to just capture it onto the same device. We'll often want to also capture that data to a second device as well. So for that, I have another i.MX 8 board, which I can also run the ETDB console on. And on this board, we're starting with a different, now remote database that is also empty. So I'll create the same table there. And I can use the built-in distribution features to receive changes to this table from other devices on the network. So I just have to enable that data distribution capability, and that will allow this second device to receive data. And then on the first device, I'll go to its persistent database and tell it to distribute its table out. And then I can just tell it to communicate this data to the remote database at the IP address of the other board. And so by doing that, now, as soon as I start inserting data into the high temperature events table again, like so, this is going to start capturing data and sending it to the database on the other device. And so you can see we've already started to receive some of that new data that was originally processed and captured on one device, has now been sent to the database of yet another device. And so now we can use this technology to collect data together from many different sensors. They can all communicate into the same table. And we can do even more interesting queries, such as a query to find out which of the drilling machines is experiencing the most frequent of these temperature spikes. This is, of course, randomly generated data over the last few minutes, so it's not very accurate, but you can see that any device with the greatest total amount of time spent in a high temperature, these high temperature events will show up on the top of this list. And this is really great for maintenance so that you can identify what drills may need to be retooled or swapped out in order to keep them working at optimal performance. The exact queries that you're going to run are, of course, going to vary depending on what problem domain you have, but this is a great way to really dig into the data that's been captured with the full flexibility of SQL query language. So, as I mentioned before, it's also important to make sure that any data you capture is properly secured. And so we have a built-in Idia DB Seal security expert agent library that is able to monitor how the database is supposed to be used and use that information to watch for incorrect usage when the database is accessed by various clients. And so we can train the database on a number of different queries that we want it to be allowed to run. And then when we are ready to deploy the application, we can enable a watchdog to make sure that the only queries you can execute are the ones that were vetted by the developers, and any other queries that do not match are going to cause errors for anyone that tries to attack and use an unauthorized query. So this really allows you to very strictly control the type of access at the device level itself. And as we've seen with this demonstration, the development tools that we provide are really a big part of what makes this easy to understand what's happening on the devices, where the data is coming from, what format it's in. And so we provide the ETDB console to developers so that they can design their queries and schemas, so that they can generate simulated input and gradually transition that to actual inputs. And they can also model the distribution of the data across various devices. Today I use two databases with exactly the same schemas, but you don't necessarily have to use precisely the same schema to distribute the data. And so this really allows you to build up the design, understand what the devices you're targeting are actually capable of before committing to writing any C or C++ code against the database library directly. And of course, it's just nice to be able to remotely access that data from within your web browser. So I hope that this has provided a good overview of what you can expect with ETDB SQL.
Thank you, Ryan, for that exciting demo. Now let's break it down. We're going to give you a quick walkthrough on the steps that we took to accomplish this demo. The first is the processor selection. After that, we're going to look at different hardware platforms and what solutions are available. And then we're going to explore all the options that Idia provides to us as far as application development goes. First, we're going to pass it to NXP, where they'll guide us through the i.MX 8M series of processors, and they'll explain to us why the i.MX 8M Mini is the best option for this industrial automation demo.
Thanks, Fernando. I'm Justin Mortimer, Global Marketing Director for NXP's Edge Processing business. For those of you on the phone not already familiar with NXP, We're a company of nearly 29,000 employees and supporting over 26,000 customers that really span countries around the world. It's our focus to help bring advanced technology to the masses and accelerate your breakthroughs so that you can focus on your application development and bring value to the broader market. In order to do that, we know that we need to have a commitment to you and a commitment to our products. And to demonstrate that, one of the many things that we bring is a commitment to longevity. Our application processors offer a minimum of 10 to 15 years longevity. You can find more information about the longevity program on nxp.com. Another point of demonstration to our commitment is the strenuous qualification we put our devices through before we launch them to the market. Many of our devices meet the harsh industrial, always-on, 10 years, wide temperature and voltage ranges that are often found in many of your applications. It's this type of work that we put into our devices that helps ensure that you can build trust in the products that you're buying and using across your applications. But to really be able to address the broad range of markets that we support, we also need to have a scalable portfolio ranging from entry-level Cortex-M MCUs and connectivity up through our crossover processors, the i.MX RT and the ULP products. But the focus of this webinar, and a big focus of our R&D, is the i.MX and Layerscape portfolio, our multi-core processors that help enable advanced HMI and advanced industrial connectivity, machine learning, and securing the edge. These are all things that we're doing with our application processors. But it's not enough to just have great silicon. We need to have scalable and reusable software with great tools and solutions that help make it easier and faster for you to get to market. NXP can't do it alone, and this is why we have great partners around the world to help enable these advanced devices. And the i.MX 8M family is our newest and general purpose edge processor for the masses. This is a Cortex A53 platform offering software compatibility from top to bottom and options with pin compatibility. The 8M Mini has become the most popular place to start because it offers a balance in power and performance and integration so that you can move up or down depending on the needs of your application. The 8M Mini is a great place to get started. If you find that you need less performance and maybe a smaller footprint, you can move to the Nano UL. If you need more advanced accelerators and a wider range of integration, you can move up to the 8M Plus. We recommend the 8M Mini because we think it offers a great point of entry for the popular 8M family. Thanks for your time, and back over to PHYTEC.
Now that we've decided on the i.MX 8M Mini processor, it is time for us to look at all the different hardware platforms available. This is where a Systema module can become a very interesting solution for us. What is a Systema module, you may ask? Well, a SOM is a credit card size or smaller PCBA that modularizes all your basic components in an embedded system. This includes your processor, your RAM, your flash, your power management, different I/O, and also your interconnect. And you may ask me, why should I use a Systema module? What are the advantages? I have a few of them here for you. There's many, many more that you can see in our website. First one, it says it's an insert-ready solution to reduce your time to market. We can sometimes reduce your time to market by 6 to 18 months. That's significant. You can reduce your cost and also your resources spent on that project. It is a high-quality industrial design geared towards the most critical applications, such as medical or aerospace. And it's also designed for 10+ year longevity. This is focusing not just on hardware, but also on software. PHYTEC has an i.MX 8M Mini-based Systema module. This is under our 5-core family of products. The 5-core i.MX 8M Mini is a compact design packed with features. It's a 40 by 37 millimeter PCB. It includes different features such as MIPI DSI to LVDS converter, Ethernet PHY, and many, many others, still keeping it in as a low power, fanless design. It takes advantage of a BGA style interconnect that gives you a seamless integration into your carrier board while still bringing in a high number of signals. To be specific, 319 pins. How do I get started with this product? This is where the development kit becomes very helpful. The development kit includes all the things that you need to get started through your development. First off is a single board computer. Single board computer is the connection between our SOM and the carrier board. The carrier board expands on all the features that the SOM already has available. Some of these are CAN through our SPI-T CAN converter, RS-232, PCIe, and many, many others. We've also included a pre-certified Wi-Fi Bluetooth module, which can be used as a reference design as you move forward according to your requirements. Now you're wanting to learn more about this product. Go ahead and take out your phone and scan that QR code. It will take you directly into our website where you can learn more about the product and take a look at all the technical documentation that we make available, such as our hardware manuals or our how-to guides. Now that we've decided on our hardware platform, it's time for us to look at software. PHYTEC provides a Linux BSP for all of our products. Our Linux BSP is a Yakto project-based BSP, but we don't stay there. We go past that. We offer different operating systems that adapt to your requirements, such as Android, FreeRTOS, and other proprietary RTOS. As you move forward with your software development, PHYTEC can provide you assistance all the way on that low level, going up to that Linux stack. And as you get to that user application, this is where partners such as Idia can become a great assistance with their knowledge and expertise. I'm going to pass this on now to Sasan, who's going to talk to us more about all the efforts and the work that they did to develop the application software for this demo.
With this demonstration, we introduced you to an important option for monitoring, collecting, and storing time series real-time data on MPUs, which is also possible to do the same on MCUs or microcontrollers. In our specific scenario, sensors continuously poured a fresh stream of data to a gateway PHYTEC i.MX 8 Cortex-A device, where we selected important events and only stored valuable information for offline analysis queries. We also showed how connected devices can communicate and talk to each other via database engine so they can distribute and communicate information internally and externally. Our database technology can scale up to refine terabytes of raw data into kilobytes of useful information. And with IoT and the new era of modern autonomous and automation, manufacturers are building applications with new architecture to really understand and make sense of raw data that is coming from the sensors. While there's a great marketing emphasis on moving application data off premises and into the cloud because of security concerns, bandwidth costs, slow communication, and data maintenance costs, many manufacturers prefer to do data management locally on the embedded system. Also, machine learning, alarm monitoring, and similar scenarios are safer, more efficient, and responsive when performed directly on the edge. Our demonstration is a typical IoT deployment, so where device manufacturers seek a scalable edge data management solution to deploy hundreds of devices. So each can collect, analyze, and manage a flow of data in real time without losing performance. As they will be also adding more devices after deployment, performance is critical, and they want to make sure that that linear zero remains as they expect. So these devices do not store all real-time data permanently. They monitor the entire data, capture important information, and store critical finding for future offline analysis. IoT systems heavily utilize sensors and devices to gather data, and it's important to embed the right data management and processing software into the MCUs and MPUs application that are monitoring and processing data at a very high rate. ITIA SQL is a high-performance database for building and embedding applications on MCUs and MPUs that allows the device to monitor entire data real time, and it directs specific information to store for offline analysis with desired queries. ETI SQL also offers the device to communicate with other devices and other embedded systems through standard network protocols. It has two powerful engines which are integrated for data processing as well as data management. So edge device can keep up with the large quantity of data flowing within short intervals at the high volume. And with this demonstration, the data processing engine offered filtering, grouping, and analyzing data so device can separate important information such as events from raw massive data. And as data needs to be rapidly analyzed to extract the immediate and useful insights, so edge devices can make fast decisions every milliseconds or every microseconds. With our scenario, we empowered the PHYTEC devices to manage and process data locally on the edge. Um, After important information is processed via data processing engine, data management engine is available with ITIDB SQL to store information so you can run queries and understand system behaviors, including configuration, logging, or any other desired data. So you can simply benefit from your database experience and feel like home with a database that has SQL. You can store data on disk, on memory, or hybrid, and distribute the data within the devices. And your previous experience with databases comes really handy when you develop with ETIDB SQL. The data distribution that ETIDB SQL offers protects a system of devices to share data. Redundancy is a key aspect for high availability as it allows data to be kept in more than one device and eliminates a single point of failure. High availability is often used with server environments as a safety feature to protect critical data. And now we have it for the devices. And during our demonstration, we shared a way to make data-driven devices easily replaceable in the same way with our database. And because ETIDB SQL devices deployed are saved from corruption, the corruption that happens due to power loss, and other devices when such a situation happens do not lose access to the data that they need. And the distribution feature of the ITTIA DB SQL continuously duplicates database tables. And in general, DataDB SQL is an edge IoT database that is cross-platform, supporting many operating systems and Linux, Windows, real-time operating systems, and will offer you to reduce development time and cost. So each time that you have a new target, you want to capture a new market, and you need to reuse the database code, it's available. All you need to do is just deploy it to the new environment. So database code can easily be migrated to the new desired operating system and hardware architecture. So manufacturers that they developed with ITTIA DB SQL, they greatly benefit its portable API across desired operating systems and hardware devices. So instead of writing fresh code for each port, database code is reusable, which saves tremendous development time and maintenance cost for device application development. Another important factor is the safety and security of data, and that's a concern for manufacturers as the devices are increasingly becoming the target of purposeful advanced cyber attacks. Security solutions that are available must ensure the device has not been interfered with and the data remains secure on the device, and the communication remains secure, and the data is protected from attacks. And we achieved that in ITTIA DB SQL with a number of different offering. One, it's very unique to us, is DB Seal. DB Seal is a security expert that SEAL is Expert Agent Library, Security Expert Agent Library, or DB Seal, which is a virtual agent that monitors the database responsibilities, input, and data matrix in real time and respond by rejecting unexpected requests. This offers manufacturers of embedded systems a capability that they can stop database-driven attacks where malicious codes is inserted to exploit the security vulnerabilities. And this proactive monitoring of the data and database by DB Seals allows the device to issue an alert, block access, or even shut down when the data management metrics fall out of the expected range. In addition to DB Seal, we offer a way to secure file storage, remote access, data distribution. So whether a database file is accessed locally or is shared over public network, the encryption support ensures that data is protected from unauthorized access, eavesdropping, and session hijacking. And today demonstration highlighted the value that the DB SQL database brings to the device development. And the most important thing is the integration that's available for you. You know, you can benefit from the database software that is already tested and deployed on PHYTEC, i.MX 8, and also the support that you get from the team that already have integrated this solution, tested this solution, we provide getting started guide, and anything that you need that you can just, in a very rapid fashion, get the database, get the hardware, and get the other tools that you need, and focus on your business and build your application as you desire.
Thanks, Hassan. Now, how do you get started with your industrial automation project? First off, you can give it a try. You can buy a 5-core i.MX 8 minute kit through the PHYTEC website. You can also access the application guide, which shows you exactly how to replicate this factory data management demo that we just showcased. You can also attend a workshop These are half-day live trainings that cost $299. It does include a free 5-core i.MX 8M mini kit. The first one is on May 20th for North America, and the next one's on May 27th for Europe. Lastly, you can get in touch with any of us here. The QR code shown in there has all of our contact information, and we would love to hear about your next project. So thanks for joining. Now I'm going to pass it on to NXP, who's going to moderate our Q&A.
All right, thank you so much, Fernando. Thanks to all our presenters for the great information. Now it's time for the Q&A. Before we go into that, though, I did want to point out that the link for that workshop from ITTIA is in the chat window of your GoToWebinar interface. So the first question that we have, can this same demo be run on other NXP platforms like i.MX 8M Nano? Let's let Fernando start that off for us.
Yes, the quick answer on that would be yes. So we can easily transition on the sound side from an i.MX 8M Mini, which is what you're going to see on the development kit normally from PHYTEC, and then you can seamlessly transition to an i.MX 8M Nano on the same SOM footprint. So the software support and everything is already included from PHYTEC's side, making it a lot easier for you to do. I don't know, Justin, do you want to add anything on the just on the processor side about scalability of this family of products?
Yeah, sure. Thanks. Yeah, like I was saying earlier, I mean, we really tried to build the 8M family much in the same way we built i.MX 6 years ago, but really offer scalability both in power, performance, integration. You can go down to the Nano or the Nano UL, which we're launching here in the coming weeks and months, and rolling that out on the lowest end with the smallest package, or go up to the 8M Plus, like I said earlier, you know, with some additional accelerators, multimedia, industrial connectivity, and so on. So yeah, I mean, I think the Mini is a really good place to start. It's kind of right in the middle, and obviously there's a great solution here that we went through, a great place to get started.
Okay, thanks to both of you for that. The next question, does Idia provide training and support for basic database programming? I know the basics, but I am not a database expert. We want to hand that over to Idia for an answer. Ryan, are you there?
Yes. So ITTIA does support, provide the training and technical support necessary to develop applications. We fully support our products and really try to become the database arm of any company that is building applications for devices. We understand that designing a database schema and developing application code that makes the most optimal use of the database library is not necessarily trivial, and we provide all of the support necessary to make the most of that.
Yeah, in addition to what Ryan explained, we have a workshop that is sponsored by PHYTEC here, and the fee for that is completely removed. So if you register today, you don't have to pay anything. It's for free of charge. It's the registration code is PHYTEC, and with that you can register and benefit from that. And as Ryan explained, majority of the challenge that database developers are facing comes from the fact that you know, they don't know they are familiar with database at the general level, but they have questions with integrating the hardware and the operating system and other tools, and that takes months and months. But the benefit that you know, you people receive, it's PHYTEC and NXP and ITTIA are partners, and this partnership is really valuable because what will offer you is they have tested the software that instead of you spending, we have seen people spend, up to a year or two, believe it or not, to put everything together. And by the time that they run out of the budget, they want to focus on their own business. So basically, the value of the partnership is something that's integrated, hardware, software. Just get it, start working your development. And when you have any questions or any support or any training, we are here to support you.
Great, thank you. The next question is for ITTIA as well. The question is, does the demo integrate into Yakto?
Yes, it does. The demo that we showed today runs as a standalone executable, so it can be just directly copied to a target device, but we also provide the BitBake recipes for integrating both the demonstration through the DB console utility and